Dora Strelkova. She's doing her Master's of Mechanical Engineering at the University of Windsor. And the title of her presentation is "You Wouldn't Want a Pie Filled with Holes, so why should we accept 3D printed parts with them?"
Your 3D prints are catfishing you. And let me explain with a slice of pie. At a diner, you order a delicious lemon meringue pie. The top is golden, the crust is crisp, and on the outside, it looks flawless. But when you slice into it, your slice is riddled with holes. Weird. Well, the same idea kind of happens in 3D printing, where the outside of your part is smooth to the right tolerance, but inside are hidden voids that weaken its structure. And unlike pie, where those holes are disappointing, in 3D prints, those can lead to extreme part failure. So why does this happen? In 3D printing, we make parts layer by layer. And there's different types of 3D printing, but my research focuses on the type called material extrusion, where we push hot plastic through a hot nozzle and color in each layer by layer until we build that part. On the left of my slide, you see a square layer. That layer has intentional circles in it, and then a zigzag pattern that we use to color it in. But notice how the corners are missing, and there's small holes in between. Those small holes are what we call voids. And when we expect a solid plastic part, those voids are the problem. So let's just fill the voids, right, and then problem solved, huh? Well, no, it's not that easy, actually, because when you print a part flat, it might be super strong. But then flip that same part 90 degrees, and suddenly it's 90% weaker, even though it's the same material. And we see that in the beautiful data I've collected that I've simplified for you in my bar graph, where experiment B was printed flat and super strong. That tells us that we pulled the part along the layers. But experiment C, well, yikes, not so good. Same material, same part, printed flat, and pulled across the layers. How inconsistent. On the right, we have some failure zones of my parts that we see, again, same material, inconsistent. Why do we care about this inconsistency? Well, the last thing you want is a 3D print in the car you drive, the plane you fly in, or that medical implant in your hip to fail in an unexpected way. Because at that point, that failure is beyond inconvenient like your pie. It's absolutely dangerous. So what do we do here? Well, we can't change that 3D prints are built layer by layer. But what if we redefine that layer? Because no rule says it has to be 2D. So that is my research, exploring 3D layers that interweave and reinforce each other in the critical zones, so our bar graphs can all reach the same height, consistency. Because you wouldn't want a pie filled with holes, so why should we accept our 3D prints with them? Thank you.